at Seldon. And yeah, today I'm gonna kind of walk through the Seldon Core integration that ZenML have, and kind of give you the view from like the other side of the fence, right? Because you've probably seen it already from the ZenML side, and what that kind of looks like to us, and why we think that's really awesome as well. So I think I'll just stop by sharing my screen, and then we'll go from there. Cool. All right. Hopefully you can see that all right. Can someone just confirm?
Yes.
Oh, okay, we're good now. All right, I'm going to do a super quick couple of slides. In fact, no, I'm going to jump to the GitHub repo first, because I'm going to make some assumptions that people on here are kind of at least familiar with the basics of ZenML, but maybe haven't heard of Seldon Core, right? So what Seldon Core is an open source framework that deploys machine learning models on top of Kubernetes. So that's it at like the highest level. And then, if you dig a little bit deeper, you realize that it kind of creates these REST gRPC microservices in there that run your model either bundles your model into a container or runs it on top of a like prepackaged inference server, which has like optimizations for whatever framework you're running, etc. And then if you dive even deeper, there are loads of cool functionality for things like inference graphs and so on. You can find out more about it. You just go to Google Seldon Core or jump on GitHub and find it, and then you can jump to the docs from there as well. If you click this little play logo, you get a nice video from me on YouTube, which is cool. So shameless self plug there. But that's like a 5-minute overview of what Seldon Core is. Cool. So I think probably the easiest way to explain some of the features is to do it like a super quick slideshow. So apologies for this. I'll dive into the code in a second. Okay, the first thing I wanted to mention, which is cool that you get with Seldon, because often people say like, yeah, okay, I could use a framework for this. But as you saw in the question that Dixon posted, you can just use like Fast API or Flask or something and just wrap your model in an API yourself and then deploy it. So like, why should you use a framework like Seldon Core? And the answer is, well, firstly, like consistency, but then secondly, there are like a bunch of cool advanced features that you can use. So one of them is the inference graph, which allows you to like chain models together, to put transformers in, do ensembles, things like that. So this really simple example here, you can see the config on the left-hand side, and on the right-hand side is like a kind of visual representation of that. And what we're doing here is just the output of model 1 gets chained into model 2, right? Really simple. That might be like word embeddings into an NLP model of some sort. But you can also build like really cool inference graphs out of these. So a more complex example might have, maybe down this left-hand side of the graph, we're seeing like an NLP model that's got input and output transformers. On the right-hand side, maybe there's some sort of tabular model that I need to I run the data through to. And then I use some sort of combiner that, based on the results of each of the model, maybe make a decision, right? And the cool thing about this is it allows you to like build all of your inference logic into your production system so that your users only have to call an endpoint, right, with their data, and then they get a full decision back rather than having to know which model to call and which order and then where to send the payload afterwards and stuff like that. You also it has support for adding metadata alongside all your models, so you can query all of that. I won't go into too much the benefits of that. People figure it out. And then it automatically will scrape metrics. If you have like a Prometheus server running on Kubernetes, it will send metrics automatically. And then it also has great integration to our open source Alibi libraries that do drift detection and explainability as well. So those are some kind of cool features, as well as a bunch of other things like auto scaling, which is one of the big reasons we use Kubernetes, is that it gives us all of that flexibility to scale things either individually or as a whole. So when I showed you that graph earlier, you could choose to scale individual components on there, or you choose to bundle the whole thing into a single pod and then scale the whole thing at once. We have custom language wrappers for things like R, Python, Scala, C++, etc. You can configure full request logging, which again is super helpful, right? Being able to know what all the inputs and outputs of your models are, particularly when it comes to like retraining, a month or two later, like you detected drift, right? You want an audit trail of everything that's happened. And then because it's part of the kind of CNCF ecosystem on Cube, you can do things like using Jaeger for microservice tracing to understand like why your model is performing in a certain way, where the bottlenecks are. And then we have integrations to things like Kafka for stream processing and so on. Cool, right? So that'll do. Enough slides. My job is not to come here and sell you Seldon Core, but it does give you a kind of bit of intuition to what it is. So how does it work with ZenML? Right, so what I'll do is, I think I'll just show you, the first thing to do is to show you my stack I have here. So I'm assuming people are reasonably familiar with the stack at least. If I do stack describe here, is this big enough? Make it a bit bigger. Okay. Right, you can see that what I'm running with here is I've configured a stack to use Amazon S3 as my artifact store, using the default metadata store. The model deployer, which I'll come on to show a bit more of in a second, is the Seldon kind. Now, kind is if you're not familiar, is a way of running Kubernetes clusters on your own local machine. So for me, my Kube cluster is actually running on the same device that I'm running this stuff, but it equally could be up in GCP or on AKS or whatever it is. I'm going to use the default ZenML orchestrator and then the local secrets manager as well. So a very simple stack there, but the kind of nuanced piece is that I've added this Seldon model deployer. And if I do that, let's have a look at that. Model deployer describe. And you can see this is the kind of stuff you have to configure when you add a Seldon model deployer to your ZenML stack. So because it's a Kubernetes cluster, you're essentially you can give it, well, firstly you can give it this base URL, which is basically what's the ingress URL to my cluster. So for me, that's on my local host, and you can see I'm running a port forward in the other tab over here. But if it's on GKE somewhere, you might need to give the remote URL for that. The other thing you need to do is give it your Kubernetes config so that it can communicate with that cluster. Now, what ZenML does that's pretty neat is if you don't specify one, it just automatically picks up your any local config that you have running in your terminal. So that's kind of a neat way to do it. And then the final thing that's important is to give it any secrets you need to access your artifact store. Because the way that Seldon Core works is you give it the URI to your model. So you'd say here's my model, it's stored in this S3 bucket, deploy it. And Seldon goes and grabs that model, pulls it onto the server, spins it up with the right libraries and things and so on. But in order to do that, if it's in a private bucket, it's going to need the secrets to access that. And then, of course, you need to specify the flavor of model deployer to be Seldon rather than KServe or whatever else you're using. Cool. So then let's have a look at the example we're going to run through then. And I'll just jump through this pretty simply because it's an MNIST digit training set that you've probably seen in all the examples. But we're going to have a bunch of different steps in this pipeline. So the first of which will be this data importer here, which is going to download the MNIST data and then return the training set and the test set. Then we have a normalizer. And in this case, because it's image data, all we're going to do is just normalize between 0 and 1. So just dividing by 255 there. But you can understand that this might be a much more convoluted process depending on the type of model you've got. And then I have a trainer. So, and again, you'll be pretty familiar with all of this from ZenML if you've worked with other things. I kind of feed through those things, and then I go into a TensorFlow trainer here, which is just a simple sequential model here with a single layer in there. And then we're going to compile and fit it, and then return the model. And then the cool thing here is that we're going to have like an evaluator step. Oh, sorry, not, yeah. So we're going to do an evaluator step, which we would normally do, right? And try and, feed the test set in and check what the accuracy is. But what's kind of unique to a continuous deployment pipeline, is that we might want to do something like this step, right? This deployment trigger. And down here, what this deployment trigger is doing is saying, let's take the output of that evaluator step, the test accuracy, and then let's check that it's above a certain threshold, right? And if it is, then we can continue to deploy. But if not, then maybe we just stop running the pipeline right there. And that's a really good way of like building in checks to your pipeline so that you don't end up just deploying every single model that you train, right? Because some candidates are going to be better than others. And realistically, you're probably not going to want to deploy another one unless it's better than the previous model that you trained, right? So those are the kind of base steps of the pipeline. And then the final one is this deployment step. And this is where, like, again, the value of ZenML comes in, right? If you were writing all of this in your own custom Python, you'd now have to write like a ton of lines of code to interact with Seldon, create a Seldon configuration file, deploy through the API. But because ZenML has the integration to Seldon, you don't have to do that at all. You can just import from integrations.seldon.steps. You can import this, double click there, this Seldon model deployer step, right? And then we'll import the Seldon config as well, and you'll see that in action in a second. So those are all of the steps that we're going to work through, and then we'll combine the whole lot together in a pipeline, right? And what this pipeline looks like, again, you'll be familiar with this from ZenML. We define this continuous deployment pipeline here, and I create this little visual representation of it. So you can see, we do the importer, the normalizer, and then that sends the training data to the trainer, but the test data is kind of stored for the evaluator later. And then the output of the trainer is that model which gets evaluated. And then if the accuracy is above a certain threshold in the deployment trigger, we're going to make a decision and then run the deployer, which is going to use the model as well as that decision. So a pretty simple, fairly linear pipeline that we're going to run. So let's go and do that. So hang on. Let me just put this up so you can see again. Okay, and if you've dug into the ZenML integration docs, you'll have seen this is like the example that's in there for Seldon. It pretty much follows this. It has like some scikit-learn stuff in there as well, and this is a modified version of that one. So if I run my pipeline now, you'll see it's kind of run. I've run this earlier, so it's using all the cached versions of things, which is good. It'll be a bit quicker, and it's now creating this Seldon deployment service for me. We'll just give that a second to start up, and then we'll go and have a look at it. Okay, cool. So that has trained the model, run through the whole pipeline, decided that the accuracy was good enough, and it's now deployed it to my Seldon cluster, right? Which is, in my case, running locally, but could be a Kubernetes cluster anywhere. Let's have a look at that running model. So the first thing to do is like interact with it through ZenML, right? That's how you guys will be familiar doing with it, and probably the easiest way anyway. So let's do a model deployer models list, right? And that should get back my single model which we just deployed. Cool. And then what we can also do is then do like a models describe, give it that unique ID. And you'll see this is my deployed model sitting on my as a Seldon deployment object on my Kubernetes cluster, right? And ZenML is neat because it pulls back you can see the model URI here. So there's the output of my step that was stored here in this part of my S3 bucket. You can see when the pipeline run was that was attached to it, and it's giving us all this like nice traceability all the way back from not just like here's a model deployed on a server, but here it was run with this pipeline run, which used this version of the data, and this hyperparameter that's, so on, right? Gives you all that lineage from start to finish, which is really, really neat. And you can see that it's, the live status is up and running. Cool. Let me just show you very quickly for people who are interested and know Kubernetes, kind of what happens underneath for a Seldon deployment. So what you'll see is there's this Seldon deployment object, right, that gets created, and then the Seldon operator works on that Seldon deployment object and creates the actual pods and deployments and replica sets and services and things underneath for you. So if I now go and see, what actually does that look like, I can do like a get all, and you'll see that what's been created underneath is this pod here and it has 3 containers in it. We can go into that in the questions later if people are interested. It creates the deployment and the pods, and it also creates these services over the top that do the routing. And again, this is kind of one of the valuable things about Seldon Core, is that you just give it a model, right, and it kind of handles the rest for you. So if I went in and deleted this pod, the Seldon Core operator will spin it back up again, because the desired state is stored in this Seldon deployment up here. Cool, and you can see everything's up and running. So now what we can do is we can run some inference against it. I don't know if I will actually, I'm going to show you the inference pipeline really quickly because it's important for the change that's coming later. So let's jump in here and see. Okay, so this is the inference pipeline we're going to run down here at the bottom. Just highlighted it. And you can see that it does a dynamic importer, predict preprocessor, prediction service loader. And that step there is the one that's going to go and check what models are currently deployed on your model deployer, and then say okay, is there a model deployed with the right name, with the right service, within my Seldon model deployment? And if so, then we'll run a prediction, right? So again, a very simple thing, but it's important to understand that there's a preprocessor in here, because in a second we're going to remove that and embed that into the model itself. Okay, so let's run that one. Okay. Okay, so what I'm doing here is running that predict pipeline, basically, because we ran the deployment one already. And you can see ZenML is running this inference pipeline. It's doing the prediction service loader to check that we've got a live running Seldon deployment first. Then it's pre-processing the data, and then it's sending it in and getting this live prediction back, which is coming from our actual deployed service on Kubernetes, right? And then the final thing we'll do quickly is I'm just going to delete this one so that you can see the next one spinning up in a minute. Okay. So we automatically deployed something, built a model, deployed it to Seldon, and then ran live inference against it. That was pretty cool and pretty easy. The next thing to show is that you can also, now with the advanced integration to Seldon, you can deploy custom models. Now, why? So firstly, what is a custom model? Right, a custom model within Seldon is basically anything that's not an out-of-the-box saved Keras or scikit-learn or XGBoost model or whatever, right? If you have any of your own custom logic that needs to happen in there, so maybe you go and call an external API to retrieve some sort of features, right, before you run inference, or you do some sort of weird embedding of your model first, right, before you run inference, anything that needs to happen, or even if you have dependencies that are not normally packaged with, let's say, a scikit-learn server, you can create what's called a custom model, and for that you use a Python wrapper. Now, the ZenML implementation is more or less the same, but what it looks like is this custom model code, right? So, and what I do is I basically define, the important bit here is to define a function, which is my custom predict method. And in here, what you'll see for this is that The preprocessor that we had as part of our inference pipeline earlier, that's generally what I would say is like bad practice, right? What you don't really want to do is have somebody have to do pre-processing on their data before they send it to your model. If you're going to put a model into production, what you want to do is have an API endpoint that like any old developer can interact with, just throw data at and get the results back. They shouldn't have to have any knowledge or understanding of the model itself underneath, right? And if we look at the previous one, when we ran our pipeline, we did this pre-processor step, which is up here, right? And you can see it's actually what the pre-processor step is doing is taking my data and normalizing it. Because we trained our model on normalized data, we now have to feed it normalized data during inference. But a developer who's like working on a web front end who wants to send an image to your classifier isn't going to know that. So now you've got to like either teach them to do all of that, or better, include that logic in your deployed model. So what we're going to do here is include that in this. So we'll put this like preprocessor in, which is this preprocess function. And if you jump up here, you can see what that is doing is exactly that normalization step we had earlier. And then the other part of the logic that we included again in our original inference pipeline was some post-processing, which basically took when the prediction came back, we were getting an array of like probabilities for each of the integers between 0 and 10. Or 0 and 9, I guess. The 10 integers, yeah, between 0 and 9. Again, what's not ideal about that is it doesn't give me a single classification. So we then ran like a softmax function, and if I go and look, you can probably see it. Yeah, anyway, you can find it in the code later. And again, not ideal, right, for anyone interacting with the UI to just get a bunch of numbers that they then have to post-process themselves. So what we'll do is we'll build that into the logic of the model too. And again, we'll run this little like softmax function here, and then we can just return the actual class that we thought the image was. Cool. And so that's all included in your custom model code. And then there are like a couple of things that like you need to change about the actual model deployment itself. So let me just show you this one. I think this is the important one. Okay, so there's this, when we're running this deployment pipeline, so this bit here is me running that same continuous deployment pipeline. But this time, what I'm doing is I'm using this Seldon deployment custom model deploy step. So there are, I showed you how we, in fact, I've got it here, right? We imported this Seldon model deploy step. Oh, keep clicking on that here from the integration. Right, this time we're going to import the Seldon model custom deployer step. So back up here. And then the other important thing is within the actual config of that model deployer, we specify the implementation has to be custom, right? And then the final kind of really important piece is to specify what the predict function is. Okay, and that predict function is in our custom model code, custom predict, right, which is the one we just looked at. So this is the custom model code file, and this was my custom predict function. Okay, and that's kind of enough, right, for us to be able to deploy that now as a custom model. But something you need to understand before you just hit run on this pipeline is that the way Seldon Core deploys custom models is that it packages them into a container and then sends that, that container then needs to go and be stored on a container registry somewhere, and then it pulls that down and runs the container. So you're basically building a new container every time you deploy a new model. That's fine, right? ZenML handles that. It has good integrations to container registries, and it could do the build for you. But if you were clever and you noticed earlier, my stack here doesn't actually have a container registry attached to it. So hopefully you see this in a second. Okay, yeah, so I don't have one. So I need to add one in order to be able to deploy a custom Seldon model. So let's do that quickly. Let's do a, okay, I'll show you this one first, right? What I'm going to use here, I can't see super well because of the screen sharing thing, but is I'm going to describe this Docker Hub one, which is a container registry I configured earlier. And basically say, like, I'm going to use Docker Hub as a container registry, and that's my URI, right? That's my Docker Hub account. And then I can attach that to my stack by doing ZenML stack update, and then I call it ZenML Seldon, I think, -c Docker Hub, right? And that should update my current stack and add this container registry to it. And now I'm able to go like run that code, build it into a custom container. It'll get pushed to my container registry. Then that will get fed to Seldon, and Seldon will go and pull that container down, like it did with the model stored on S3 earlier. This time it's going to pull the container, and now it's going to start that up on top of Kubernetes for me. So let's run that quickly. Okay, I'll just run the whole thing. So we'll do deployment and inference this time. Cool. So again, like this should be quicker because I ran this and cached it earlier. But you'll see some of the like important stuff that's happening down at the bottom here. You can see that it's building this Docker image, edge ZenML continuous deployment pipeline, right? It says building image might take a while, and then it pushes the Docker image, and then it creates this new Seldon deployment, right? Which is this custom one. That knows to go and grab that container, and then it's going to pull that down, run it on my Kubernetes cluster, and then when it's started, it's now, which actually it has done, it says the deployment service has started. It's now automatically now running my inference pipeline as well, so we can check that the predictions are working. So again, yeah, let me highlight the important parts there. So it's created this top stuff is like it creating the Docker image and pushing it. And then it creates this Seldon deployment, and then it waits for it to start. And you can see the Seldon deployment is reachable at this, and there's the API endpoint. And then having done that, it's now going to run the inference pipeline, and you can see, it's done around the predictor step, and here are our results back, right? So, and if we wanted to, we could look underneath in Kubernetes and see like. That we've got those pods running in there, right, for the Seldon custom deployment. And let me just check one last thing. So let's do model deployer, models list. Just in case you thought I ran the previous pipeline, this one is definitely the custom one. What we should see here is that the model name here for this one is like the MNIST custom. Cool. And you can also see the pipeline step that was run was this custom model deployment step. So you can see, so two different ways that you can deploy Seldon stuff. It kind of makes it way more powerful because it allows you to add all that like pre-processing, post-processing logic in. Or if you have like a really niche model that isn't you're not using a framework and it's just like raw Python or something like some of the old school NLP models using things like NLTK and like bag of words and stuff like that. It would be really easy to deploy this using this custom model deployer. Cool. Right. I think I've covered everything I was going to show. Shall I stop sharing and then we can do questions?
All right. Thank you, Ed, for sharing. I'm going to go ahead and stop recording now, and we can proceed to the Q&A session.
Mm-hmm.
All right. So I'm going to open the floor to any questions from